Hi there. Today we will be discussing paper 2 of variant 2 in the 2023 October-November series. So there's a total of 26 questions in this paper. So then let's get started with the first question. Question number 1 is a question which is based on rounding. The number given to you is 24.07839. You're supposed to round it to 2 decimal places. So you circle the second digit after the decimal point, underline the next digit. Based on the underlined digit, you're going to decide whether to round it up or down. If the underlined digit is 5 or more, you will have to round it up. You have an 8 here, so definitely it has to be rounded up. So you end up getting 24.08 as the answer. Part B is also based on the same question, which is 24.07839. It's the same number. In this case, you're supposed to round it to the nearest 10. So the digit in the tens column is this 2. You circle that digit, underline the next digit, which is the 4. So based on the underlined digit, you need to decide whether to round it up or down. So you have a 4 which is less than 5, so you cannot round it up. So the answer will be 20. Let's move on to question number 2. Question number 2, write down the number that is 9 greater than -3, -23. So in this case, you have -23. 9 greater than -23 means you need to add 9 to this -23, which will end up giving you -14 as the answer. In question number 3, you're supposed to find the value of v when u is given as 30, a is given as -2, and t is 7. And the equation, the formula that is given to you, or the equation is v is equal to u plus at. So you simply substitute the values that are given here. The value of u is 30. Add that with the value of a, which is -2. You multiply that with the value of t, which is 7. So when you do 30 plus -2 times 7, -2 times 7 is equal to -14. So you have 30 minus 14, which gives you 16 as the answer. So this is the value of v. Let's move on to question 4. In question 4, you're supposed to change 62,000 milliliters into kilometers. So to change 62,000 millimeters into kilometers, the first thing that you need to understand is whether to convert a smaller unit to a larger unit or to convert the larger unit to a smaller unit. In this case, milliliters is the smaller unit compared to with respect to this kilometers. That means you're converting a smaller unit to a larger unit. That is when you know that we need to divide it. And the unit conversions, when converting kilometers to meter and then to centimeter and then to millimeter, I have written it in the side. If you are to convert millimeters to kilometers, then in that case, you have millimeters here, and then you have kilometers here. So to convert millimeters to kilometers, you need to divide it by a 10, divide it by 100, and then again, you need to divide it by 1,000. So in this case, the number that is given to us is 62,000. So this 62,000 has to be divided by a 10, 100, and then again by 1,000. So once when you do the division here, I'm going to start simplifying. I can cross out the 3 zeros here with the 3 zeros here because I can divide both by 1,000. So this leaves you with 62 divided by 10 times 100, 62 divided by 10 times 100, which is the same as dividing 62 by 1,000. When you divide 62 by 1,000, you end up getting 0.062. So this is the answer in kilometers. Let's move on to the next question, which is question 5. In question 5, the diagram shows 2 intersecting straight lines crossing 2 parallel lines. So the parallel lines are represented using the arrowheads on the lines like this. Now you're supposed to find the value of x. if you are to find the value of x that we have here, in this case, the first thing that we are going to do is, this is a parallel line, which is a straight line. This is also another straight line. So this angle that we have here and this angle that we have here will be equal because they are vertically opposite. So if they are vertically opposite means they will definitely be equal to each other, which means this angle will be equal to 50 degrees. Then the next thing that you got to do is you need to find what x is. So to do this, we're going to relate the rules. We're going to use any of the angles that are related to parallel lines to find the value of x. If we are to do this, in that case, you have a parallel line here. This is the next parallel line that we have. So I'm going to use the alternate angles in parallel lines to work this one out, which means this angle that we have here will be equal to this angle. That's because alternate angles are in the shape of letter Z, and they will be equal as I have mentioned in the side, which means this 114 that we have here will be equal to this x plus 50. So if I'm to find what x is, from 114, I need to deduct 50. So from 114, when I deduct 50, I get the value of x, which is equal to 64 degrees. So this is how you find what x is equal to. So x is 64 degrees. Let's move on to the next question. In question 6a, the number given to us is 111. You need to explain why this is not a prime number. The reason why 111 is not a prime number is because 111 is divisible by 3 as well as it's divisible by 37. So this is divisible by 3 and 37. So even if you just write any one of this, that would be fine. Question B, find a number between 110 and 120. So there's one prime number in between these two numbers. So if it's a prime number, it has to have only two factors, which can be 1 and itself. So the only number that is in between 110 and 120 that is prime is 113. In question 7, you're supposed to find the bearing of Q from P. So if you are to find the bearing of Q from P, so first identify the two locations that they have mentioned in the question for which you're supposed to calculate the bearing, which is Q and P. So I'm going to connect it with a line. The two locations that are mentioned in the question, I'm going to connect it with a line. In the question, it clearly states that the bearing has to be calculated, bearing of Q has to be calculated from P. From P explains where the bearing has to be calculated, has to be measured. That means at P, you're going to start measuring the angle. So when working out the bearing, you need to make sure that you start from the north and you go in the clockwise direction until you meet the line connecting the two locations. And this will give you the value of the bearing. This is going to be the bearing. And you need to make sure that you write using 3 digits. It's very important that you write using 3 digits. Now to find the value of this angle, now we know that the north is given here. This is east, which means I can find the value of this angle because in between north and east, there's a total of 90 degrees. The angle in between is 90 degrees, which means to find the value of this angle from 90, I can deduct 39, which gives you 31 degrees, which gives you 51 degrees, I'm sorry. So now that we know this is equal to 51 degrees, I can find the value of this angle because this one is going to be in the shape of letter C. If it's in the shape of letter C, you know that we also know that north and north will definitely be parallel. So angles in the shape of letter C will be co-interior angles, and they will make a total of 180 degrees, which means I can find the value of this angle by deducting 51, that is this angle, from 180 degrees. So when I deduct 51 from 180, I get 129 degrees as the value of this angle. Now that I know that this angle is equal to 129, I can now calculate the bearing by finding this angle here. To find this angle, around a point, the total is going to be 360. So from 360, I'm going to deduct 129. So when I deduct 129 from 360, you end up getting 231 degrees. This is the bearing of Q from P. And we already have the answer in 3 digits. So there is no need for us to add a 0. Suppose if you get if you get your answer in the form of 2 digits, if it's a 2-digit number, definitely you have to add a 0 in front. So that's a rule for bearing. Let's move on to question 8. In question 8, you're not allowed to use a calculator here, which means you need to show out the workings. In this case, you have 2 improper fractions where one is subtracted from the other, and you need to solve this. So first, when you have 2 mixed fractions, and you need to solve this to find the answer. So when you have 2 mixed fractions, your first step is to convert them into improper fractions. So to convert it into an improper fraction, I need to multiply the whole number that I have here with the denominator, and I need to add the numerator to the answer that I get, which means 3 times 8 is 24. 24 plus 1 makes it 25. So I can write it as 25 over, the denominator stays the same, which is 8. And we need to deduct the answer that we get here. So that is 1 times 4 plus 3. So 1 times 4 is a 4. 4 plus 3 is 7. So 7 over the same denominator, which is 4. When we try to subtract fractions, it's important that the denominators are the same. So I will make this 4 into an 8 by multiplying it by a 2. I do the same change to the numerator as well to multiply it by a 2. So I get 25 minus 7 times 2, which is 14. I need to divide this answer that I get by 8. Or I can say it as it's over 8. So 25 minus 14 is 11. So I get 11 over 8. This is an improper fraction as the numerator is larger than the denominator. So when you have an improper fraction, we need to convert it into mixed fraction or mixed number. So to do that, I need to divide the 11 by 8 to check how many wholes of 8, how many groups of 8 can be found in 11. So there is one group of 8 that can be found. And there is a remainder of 3. The remainder goes to the top. And the denominator stays the same as the denominator in the improper fraction that we have here. So the answer is 1 whole and 3/8. Let's move on to the next question. In question 9, write 90 as a product of its prime factors. So to write a number as a product of its prime factors, first we're going to draw the factor tree for 90. So when I draw the factor tree for 90, I can write it as 2 and 45. I can divide it by 2, I get 45. I can divide this 45 by 3, I get 15. I can divide this 15 by 3, I end up getting a 5. So all these n's that we have here, they are all prime numbers. So that is when we know that we have completed the factor tree. Now this 90, I can now write it using the prime numbers here as a product. So I would write it as 2 times, 3 times, 3 times 5. So when we multiply them all, it will make a 90. So I can also write this as 2 times 3 squared times 5. This is how 90 is written as a product of prime factors. Let's move on to question 10. In question 10, we are asked to expand and simplify. To expand means to remove the brackets by multiplying the terms inside the brackets with the term that is outside the bracket. So using these two, I need to multiply the t and the w. So it becomes 2t plus 2w. The same way, I need to do the same thing for the next bracket as well. So using these 3, I need to multiply w and t. So 3 times w is 3w. They both are positive, so you get a positive answer. 3 times t is 3t. The 3 is positive, the t is negative. So when a positive number is multiplied with a negative, it becomes a negative. So this is what you get. Now you need to combine like terms to simplify this. So 2w and 3w makes 5w. 2t minus 3t is equal to minus t. This is the answer. Let's move on to question 11. There are two shapes given to us, and it clearly states that the two shapes are mathematically similar. If any two shapes are mathematically similar, then there's something to do with the scale factors. So we have something called the linear scale factor. So if the linear scale factor is x over y, then the area scale factor, to find the area scale factor, this linear scale factor has to be squared. If you are to calculate the volume scale factor, if you have a question relating the volumes of similar shapes, then you need to know the volume scale factor. So you need to cube the linear scale factor to find the volume scale factor, and then you need to work out the question. In the first question that is given to us, you're supposed to find the value of h. We can do this question in the form of fractions, as well as we can find the scale factor in the form of a decimal as well. So I'm going to go with the fraction. So the two matching sides are 9 and 5. So these matching sides in similar shapes are called as corresponding sides. So the 9 corresponds with this 5. So I'm going to write the area, the side length of the larger shape on top and the smaller shape at the bottom. So I'll write it as L and S like this so that it doesn't confuse us. So the larger shape's value 9 is written at the top. The smaller shape's value 5 is written at the bottom. So those two are the matching sides. The matching sides is written in the form of a fraction like this. This, when you simplify, will give you the scale factor. Or you can even do it as 5 over 9, and that can be considered as the scale factor as well. But you need to understand when to multiply and when to divide. So you need not to get confused. I'm going to go with the fraction. So this is equal to. Now I wrote the value of the larger shape at the top. So in the larger shape, the other value that is given is 6.3. I will write it at the top. And the smaller shape's value that is corresponding to the 6.3 is h. So I should write that at the bottom. Now, if I'm to find what h is, I need to isolate h. So when you have two fractions like this with an equal sign in between, to find the value of the variable, you need to cross multiply and isolate h. So when we cross multiply this, you get 9 times h is equal to 5 times 6.3, which means if I'm to find what h is, I need to multiply 5 by 6.3 and divide the answer that I get by this 9. So this gives you the answer for h, which is 3.5 centimeters. Let's move on to the next question. The area of the smaller shape is 16 centimeters squared. Calculate the area of the larger shape. Now, this question is to do with the area, which means you definitely have to make use of the area scale factor. This 9 over 5 is the linear scale factor. So if you are to find the area scale factor, I need to square this linear scale factor. So when I square this square belongs to 9 as well as this 5, which makes 81 over 25, which is equal to the area of the larger shape should be written at the top, and the area of the smaller shape should be written at the bottom. But the area of the larger shape is not known, so I'm going to label that as A, which we are supposed to calculate. And the area of the smaller shape is known to us, which is 16. So I'm going to put that at the bottom. So if I'm to find what A is, just like I did in the previous step, I need to cross multiply to find what A is. And I will have to isolate A. So in this case, I need to do A times 25, which is equal to 81 times 16. And if I'm to find what A is, I need to divide the answer that I get when I multiply 81 by 16, 81 times 16, I need to divide that by 25. So when I do this, I end up getting 51.84 square centimeters as the value for A, which means this is the area of the larger shape. Let's move on to the next question. The next question is question 12. In question 12, a speed time graph is given to us. The diagram shows the speed time graph for 16 seconds of a car journey. Find the deceleration of the car in the final 6 seconds. So in the final 4 seconds. So in the question, they have mentioned that the deceleration is in the final 4 seconds, and that is what you're supposed to calculate, which means you need to find the deceleration for this section that is mentioned. Deceleration is negative acceleration. So you're going to make use of the acceleration formula, which is the difference in speed divided by time. So the difference in speed is going to be from 10, I need to deduct this 0. So when I deduct 0 from 10, it is a 10. I need to divide that by time. So the time from here to here will be 4. So this will give you the acceleration, but this is going to be negative acceleration, which means that's the deceleration. So I'll write it as D here so that we know that that's going to be the deceleration. So this is equal to, I need to divide 10 by a 4. When I divide this 10 by a 4, I end up getting 2.5 meters per square second. This is the deceleration for this region. Let's move on to part B. In question B, find the total distance traveled during the 16 seconds. So the 16 seconds is from 0 all the way up to 16 means if you are to find the distance traveled using a speed time graph, you have to calculate the area under the graph. The shape that you have here, the area under the graph, the shape is a trapezium. So to calculate the area of a trapezium, we add the parallel sides together, divide it by 2 and multiply it with the perpendicular height. In this case, these two are the parallel sides. So the distances are from here to here, it's going to be 12. And from 0 to 16, the distance is 16. So we will have to add 12 and 16 together, divide this by 2, and you need to multiply it with the perpendicular height. Perpendicular height is the distance between the two parallel lines. That's from 0 to 10, which is a 10. So when we do this, so you have 12 plus 16, you add them, divide it by 2 and multiply by 10. This will give you the distance traveled. So in this case, to calculate the distance traveled, when you put this in the calculator, it gives you 140 meters. The reason why it's meters is because the units given for speed is meters per second, which means it's going to be in meters. Here, the D in the previous question, for question A, the D that I have written here is deceleration, not distance. Okay, let's move on to the next question that we have. In question 13, you're supposed to find the value of P for question 13A. So to find what P is, I'm going to write this 729 also with a base of 3. So then I can write it as 3 times 3 to the power 3P times 3 times 2P, 3 to the power 2P, which is equal to 729. This 729, I can write it as 3 to the power 6. Now that the bases are the same, we can equate the indices. And we know that when two same bases are being multiplied together, you need to add the indices, which means I need to add this 3P and 2P together, which is equal to the index that we have here, that's a 6. So when we add this, I get 5P, which is equal to 6, which means the value of P is 6 divided by 5, which is equal to 1.2. Let's move on to question B. You need to simplify this. So you have 32x to the power 10. The entire thing has another power of 1/5. So here the power that we have is a fractional index. So I'm going to write this 32 with 32 so that it has a power of 5, because here the fractional index, the denominator of the fractional index has a 5 in it. So I'm going to write this 32 as in the index form so that it has an index of 5. So an index of 5 or a multiple of 5. So I can write this 32 as 2 to the power 5. I have x to the power 10 and this entire thing to the power 5. This power 5 belongs to the terms that are inside the brackets. So this power 5 will get multiplied with this power 5 as well as this power 5, because a number, when it has two powers, the two powers should get multiplied together because it is called as the power of a power, which means I could write it as 2 to the power 5 times 1/5. And this x to the power 10 also should get multiplied by 1/5. I can simplify this 5 with the 5 by dividing both by a 5. This 5 and this 10 also can be divided by a 5. So you get a 2 here and a 1 here. So here this becomes 1 and 1. So this gives you the answer 2 to the power. 1 times 1 is a 1, so I can leave it as a 2. Then x to the power 2 times 1 is 2. So our answer is 2x squared. Let's move on to question number 14. In question number 14, you are supposed to rearrange the formula to make W the subject. To make W the subject, there is a number as well as a variable that is connected to this W. So you need to remove both of them. But the one that has to be removed first is the one that is furthest from W or is loosely bounded to W. So then minus x is the furthest from W. So I need to deduct that. I need to get rid of that from W. So it's being subtracted. So if I'm to take it to the other side, I need to add it to the other side. So it becomes y plus x is equal to 2w squared. Now I need to get rid of this 2. The 2 gets multiplied with w squared. So to get rid of this 2, to take it to the other side, I need to divide by 2. So this gives you w squared. So now I need to find what w is. I need to make w the subject. To make w the subject, I need to get rid of the square that we have. To get rid of this square, I need to do the square root of the other side, because only then the square and the square root will cancel out, which will give you y plus x over 2, and you have the square root here, which is equal to w. But the moment you put the square root, it's very important that you put the plus and the minus sign, because the square root of a positive number will always have two solutions. It will have a positive solution as well as a negative solution. So it's very important that you put the plus or the minus sign in front of the square root. Let's move on to question 15. In question 15, on the Venn diagram, shade the region P union Q complement. So I'm going to draw a small shape in the side. I'm going to explain what's really happening here. And then the final answer, I'm going to put it in the diagram that is given in the question. This circle is labeled as P. This is labeled as Q. So first P means I need to shade the entire circle for P. This is the entire circle for P. The next one is Q complement or Q prime. It means that everything except Q should be shaded, which means I'm going to shade in everything apart from Q. So I'm going to shade in this region. And there's a region that belongs to P that has to be shaded too. And yes, this is how I should be shading. So I accept this circle Q, the Venn diagram Q, everything else has to be shaded. Now union explains that whatever that is shaded has to be considered as the answer, which means it may have just, now according to this, I have used two different colors. So when, like in this case, as I have used two different colors, we can, like the answer will be everything that is shaded means it can have just one color or both the colors, which means our final answer is going to be like this. So I'm going to shade in the final answer. So it will have this region, and this is how it's going to be. Apart from this region, everything else has to be shaded. In question B, the number of elements in the universal set is given as 20. So I'm going to mark this in the Venn diagram because you need to complete the Venn diagram. So I'll just put this 20 here so that it doesn't confuse us. Then the next one that is given is the number of elements that belong to A union B complement is equal to 1. A union B means everything that belongs to A and B. A union B complement means except that, but everything else. That means but the rest, which means the region that is outside the circles is 1. So I'm going to put that 1 here. And the number of elements that belong to A is 12. So A has 2 regions, which makes a total of 12. So I'm going to put that 12 here because I cannot put it here or I cannot put it here. The same way, when it comes to number of elements that belong to B, it is 10. So that means it includes both these regions. So I'm going to put that 10 on the edge of the circle like this. Now I need to fill this by completing these spaces. I need to fill these spaces here. Now all three spaces are not known. As all three are not known, to find the missing value, to find these missing values, what you got to add is you got to add this 12, 10, and this one that is outside the circle, the one that is outside the circle, and the two numbers that represent these two circles has to be added. When I add them up, it gives me a total of 23, but the actual total, the number of elements in the universal set is 20. I need to deduct that 20 from this 23, which gives you 3. This 3 is the number that goes in the middle like this. That is the one that goes into the overlapping region. Then now I can find this missing number because in circle A, circle A has to make a total of 12. So if this is 3 means this has to be 9. This is 3. I can find this because it should make a total of 10, which means this has to be a 7. This is how we complete the Venn diagram that is given. Let's move on to the next question that we have, which is question 16. Find the lowest common multiple, LCM, of 12x to the power 8 and 8x to the power 12. So the two terms given to us are 12x to the power 8 and 8x to the power 12. So I'm going to first draw the factor tree for the two numbers. So when I draw the factor tree for the two numbers, so I have 12 and 8, I can divide it by 2. 12 can be divided by 2, you get a 6. 6 can be divided by 2, we get a 3. This 8 can be divided by 2, you get a 4. Divide the 4 by a 2, we get a 2. Which means this 12, I can write it as 2 to the power. So I have 2 2's and a 3. So I can write it as 2 to the power 2 times 3. I also have x to the power 8. So I'm going to write x to the power 8 as well. The same way, when I consider this 8x to the power 12, 2 times 2 makes this 8. So I can write it as 2 to the power 3. I need to times it with x to the power 12. So I'm going to write it this way. Now what I'm going to do is, if you are to find the lowest common multiple, now I need to check the 2's here, the numbers. There are two different numbers here. So that's 2 and 3. In each of those groups, you need to select the term with the highest power or the term that is the highest. So when we consider the 2's, you have 2 to the power 2 and 2 to the power 3, which means I can pick 2 to the power 3, which is the highest. Next, the number that we have next is 3. So I have 3 only in 12. I do not have it in 8. So that's the highest anyway. So I need to pick that as well. Then when we consider the x's, so we have x to the power 8 and x to the power 12. So x to the power 12 is the highest. So I need to pick that. Now simply I need to multiply them all. So this will give us the lowest common multiple. So 2 to the power 3 is 8. 8 times 3 is 24. 24 x to the power 12 is the lowest common multiple of 12x to the power 8 and 8x to the power 12. Now let's move on to the next question. Question 17 is a question that is related to circle theorems. The points A, B, and C are on the circle with the center of the circle is O, and the angle OBA is given as 28 degrees. We need to find what ACB is, which is this angle. So for us to do this angle, I'm going to first consider this triangle that is given to us. In this triangle that is given, OB is a radius to this circle. The same way, OA is also a radius to the same circle because it's from the center to a point on the circle. So definitely these two will be equal. This makes the triangle an isosceles triangle. As this is an isosceles triangle, we know that in an isosceles triangle, the sides, if two sides are equal, two sides will anyways be equal in an isosceles triangle. The angles opposite to these equal sides also will be equal, just like I have shown here, which means this angle is 28 means this will also be 28. Using these two angles, I can find the value of this angle now because the angle sum of a triangle is equal to 180 degrees. So for me to find the value of this angle from 180 degrees, I can deduct these two angles, which is 28 and another 28. So from 180, when I deduct 28 and 28, I get the value of the angle as 124 degrees. This 124 degrees is the value of the angle that we have here, which is AOB. So this is 124 degrees. Now that I need to find what ACB is, so here ACB is an angle that is formed using the same points A and B, but on the circumference, whereas this angle AOB is an angle that is formed by the same 2 points, which is A and B, on the center. Which means we can use the circle theorem that we have here, which explains that the angle in the center is twice the angle in the circumference of the circle, which is formed by the same arc or the same chord. Which means if this is 124 degrees, I will be able to find what this angle is, because this is the angle at the circumference, which will be half the angle that is formed at the center of the circle. So I need to divide 124 by 2 to find that, which will give you the value of this angle ACB, that is 62 degrees. So angle ACB is 62 degrees. Let's move on to the next question, which is question B. In this question, P, Q, and R are points on the circle. TU is a tangent. So a tangent is a straight line that hits the circle at just one point. So it touches the circle or hits the circle at this point P. And the angle TPR is given as 47. We need to find what PRQ is. PRQ is also given to us, which is 52. We are supposed to find what RPQ is. RPQ is this angle. So this is the angle that we are supposed to calculate. Now, as the term tangent is mentioned, and as an angle is formed using this point P, then we need to understand that this is something to do with the alternate segment theorem. According to the alternate segment theorem, the angle that is formed between the chord and the tangent will be equal to the angle that is subtended by that same chord in the alternate segment, which means this angle and this angle will be equal. The same way, I can consider this as the tangent, this is the tangent, and I can say that this is the chord that we have. So using this chord, they have formed an angle here. So this angle and this angle will be equal, which means this will be 47 degrees. The reason why this is 47 degrees is because of the alternate segment theorem. Now that I know this is 47, I can now calculate how much this angle is. Because two angles in a triangle is known, to find the third angle, I need to deduct these two angles from 180 degrees. So from 180 degrees, I need to deduct 52 and 47 degrees. So when I deduct 52 and 47 from 180 degrees, this gives us the value of the angle RPQ, which is equal to 81 degrees. This is the value of this angle RPQ. Let's move on to the next question. Question 18. A solid cylinder has a radius of 5 centimeters and a height of 8 centimeters. We need to calculate the total surface area of the cylinder. So, in a cylinder, there are instances when the formula keeps changing. It keeps changing based on the number of phases that shape has got. A solid cylinder explains that it has a top as well as a bottom, and it has this curved surface. Now, if that is the case, then we will have to make use of the formula 2 pi r squared plus 2 pi r h. But if the cylinder is a cylinder without a top, just like a container without a top or without a lid, in that case, it will have only one circle at the bottom. Therefore, we will go with the formula pi r squared plus 2 pi r h. Let's also say that now there is no top or no bottom, just like a pipe. In that case, to calculate the total surface area, we will have to go with the formula 2 pi RH, because it does not have the two circles, so there's no use writing this 2 pi r squared, and we cannot use that 2 pi r squared into that formula. In this question, as it clearly states that this is a solid cylinder, we have to make use of the formula 2 pi r squared plus 2 pi RH. And in the question, the radius of the cylinder is given to us as 5 centimeters. And the height of the cylinder is given to us as 8 centimeters. So I'm going to mark the height here. So I'll put the 8 here. So I'm going to substitute this into this formula to calculate the total surface area. So it will be 2 times pi times r squared. So 2 times pi times 5 squared plus 2 times pi times 5 times h, which is 8. So I need to solve this. So if I put this directly in the calculator, it will give us the answer. So let me show that in the calculator. So I'm going to put 2 times pi times 5 squared plus 2 times pi times 5 times 8. So this will give the answer. So the answer that I get is 130 pi, which is the same as 408.407045 centimeter squared, because this is surface area. But I'm going to write it correct to 2 decimal places, which will be 408.41 square centimeters. So the answer that I get here is 408.41 square centimeters. Let's move on to question 19. In question 19, we are supposed to find the nth term of the sequences given here. In the first sequence, I need to find the difference. So when I find the difference between the numbers, each time it decreases by a 3, which means I need to deduct a 3 each time to find the next term, or to form the next term, which means this explains, using this negative 3 that we have got, we can find the first part of the nth term, which is negative 3n. Now I need to find the next part that connects with this negative 3n. So the first amount that it decreases is by negative 3. I need to see from negative 3 how I could reach to this 11 by adding or subtracting. So to this negative 3, only if I add 14, I can get to this 11, which means this number that is being added connects with the next part of this nth term. So minus 3n plus 14 is the nth term of this sequence. In the next sequence that is given to us, it does not decrease by the same amount each time, just like we did just like in the previous one. So the previous question is an arithmetic sequence, but in this case, it's not an arithmetic sequence because it decreases by different amounts each time. But the moment you see the numbers, they look like powers of 5. That means this is going to be an exponential sequence, which means each time I need to times it by 5 to form the next number, or to find the next number, which means as it gets times by 5 each time, or is a power of 5, I can write it as 5 to the power n. But n represents any number. So if I put 1, which means if I want to find the first term, I need to replace n with a 1. When I replace n with a 1, I get 5 to the power 1, which is a 5. But our first term is a 1, which means to get to this 1 here, I must deduct a 1 from this n. Only then 5 to the power 1 minus 1 is 1 minus 1 makes it a 0. So 5 to the power 0 is equal to a 1, because any number which has a power of 0, is always equal to a 1. So if I want to check if this is right, so if I put 2 for this n, it becomes 5 to the power 2 minus 1. So 2 minus 1 is equal to a 1. So 5 to the power 1 gives you 5. That gives us the second term, which means this is the nth term of the sequence given here. In question 20, the area of the rectangle is given. The length of the rectangle is given. You need to calculate the upper bound for the width of the rectangle. So I'm going to draw a small diagram in the side so that we can visualize what's really happening. And in this question, the length is given to us as 9 centimeters. So I'm not going to put that 9 here. I'll just leave it as 9. Leave it as L there. This is the width. So if we are to calculate the area of the rectangle, I need to multiply the length and the width together. But you need to find the upper bound for the width. You need to calculate what width is. To calculate width, I need to rearrange this formula that I have. So I need to isolate W by bringing this L to the other side. The L gets multiplied. When it goes to the other side, it gets divided. So it divides the area of the rectangle. Now, I need to find the upper bound for W. Explains that to calculate the upper bound for W, we need to see what combination will give you the largest possible value for W, which means it has to be the upper bound of A and the lower bound of the length, which means the value of A is given to us as 55.2. So 55.2 is the value of A. We need to calculate the upper bound for A. So whether to calculate the upper bound or the lower bound for A, we need to see how much to be added or to be deducted. Now, it clearly states that it's been rounded to 1 decimal place, which means 1 decimal place means the value, the digit in the tens place. So that has a value of 0.1. I need to divide this 0.1 by 2. This gives you 0.05. This is the number that gets added or deducted to calculate the upper bound and the lower bound. So this is the value of A. The value of A's upper bound only has to be calculated. So I need to add the 0.05 that we found here to calculate the upper bound of A, which gives us the value as 55.25. The same way, I need to calculate the lower bound for L. So the value of L is given to us in the question as 9 centimeters. Now, to calculate the upper bound or the lower bound, it clearly states that it's been rounded to the nearest centimeter, which means it's rounded to the nearest whole number. Whole number means it's in the ones column. So the 1 only has to be divided by a 2, which is 0.5. So I need to add or deduct 0.5 to calculate the upper bound and the lower bound. But in this case, I need only the lower bound. So I need to deduct 0.5 from this 9, which gives me the lower bound of L, which is 8.5. Now, I will have to use the upper bound of A and the lower bound of L to calculate the upper bound for W, which means it's going to be 55.25 has to be divided by 8.5. So when we divide 55.25 by 8.5, the answer that we end up getting is 6.5 centimeters. This will be the upper bound for W. Let's move on to question 21. In question 21, we have two equations given. This equation, which is y is equal to x plus 1, is an equation of a straight line. Y is equal to x squared plus x minus 3 is an equation for a quadratic graph. And the two intersect at the two graphs intersect at 2 points, and you're supposed to find the coordinates of the 2 points, which means we have a graph in the shape of, we have a quadratic graph which is in the shape of a U, or it can also be in the shape of an N, but in this case, it will be like a U. And we also have a straight line graph. So the two places where they intersect is as shown in the diagram in the side here. So we need to calculate the two coordinate points, which is written in the form x comma y. So if we are to do this, we're going to make use of the substitution method. The equations given to us are y is equal to x plus 1, and the next equation is y is equal to x squared plus x minus 3. They both are equal to y, which means I can replace this y with this x plus 1 that I have here, which will give us x plus 1 is equal to x squared plus x minus 3. Now, I'm gonna isolate. I'm gonna take all the numbers to one side and make the equation equal to a 0, because the moment we see a quadratic equation, whether we are trying to use the completing the square method, the factorizing method, or the formula method to solve a quadratic equation, we should always try to make the equation equal to a 0. So that is what I'm going to do. So I'm going to take this x and plus 1 that I have here to the other side of the equation. So already in the other side, I have x squared plus x minus 3. this plus x goes to the other side, becomes minus x. Plus 1 becomes minus 1. This becomes equal to a 0. I now need to simplify this. I can cross out plus x and minus x because they are two same terms with opposite signs, so they become a 0. So I'm left with x squared minus 4, which is equal to a 0. This is the difference of squares. When we have the difference of squares, I can directly, now we may use the quadratic formula here, but I'm not going to use that. I'm going to use the factorizing method. So when we have the difference of squares, I'm going to write this inside the brackets as x minus 2 and x plus 2. So it should be the same numbers and terms go inside the brackets, but one with a plus and the other one with a minus. And the numbers and the terms that go inside the brackets is going to be like the square rooted values of x squared and 4, which is x and 2. So this is equal to 0, which means I can say this x minus 2 is equal to 0, or this x plus 2 is equal to 0, because these two get multiplied and make a 0, which gives us the value of x here as 2, and here the value of x that we get is negative 2. So we now have two different values for x, which is positive 2 and negative 2. I now need to find the y values. So for us to find the values of y is equal to x plus 1 is the equation I'm going to use, because that looks much more easier and simple. So I'm going to substitute the value of x that I found here, which is 2 and negative 2. So when I substitute 2, I get the value of y as 3. And when I substitute negative 2, I get the value of y as negative 1. So this is the value of the y when x is negative 2. So now I can write it in the form of coordinate points as written here, which is 2, 3, and negative 2 and negative 1. So these will be the coordinates. These will be the coordinate points where the two graphs will intersect. Let's move on to the next question that we have. In question 22, x is inversely proportional to the square root of w, where w is equal to 16, x is equal to 3, and we need to find x in terms of w. First, I'm going to form the equation for this. As it states that x is inversely proportional, I will write it as x is equal to, I'm going to put the constant here, which is k, over is proportional to the square root of w. So I can write it as square root of w. As it's inversely proportional, the constant has to be written at the top, and the next value that is given to us has to be written below the division bar. So this is how it should be written. Now, I need to first find what k is. To find the value of k, the value of w and x is given to us. So w is 16, x is 3. So I'm going to substitute it here. So x is given as 3, k over the square root of w, which is 16. Now, if I'm to find what k is, I need to do the square root of 16, which is 4. And I'm going to take the 4 to the other side of the equation, which gets multiplied with this 3 that we have. So this is, I can write it as 3 is equal to k over 4. And to isolate k, I'm going to take the 4 to the other side. The 4 gets divided. When it goes to the other side, it gets multiplied. This gives us the value of k as 3 times 4, which is 12. Now that the value of k is known to us as 12, I can now write the equation as x is equal to the value of k is known to us, which is 12, over the square root of w. So we need to find x in terms of w, where we need to isolate x, and the w should be there in our answer. So this is going to be the answer. Let's move on to question 23. In question 23, we are given a table where the class intervals, they are given in the form of a group, and the frequency is given to us. So on the histogram, the height of the first block that is given to us, which is 0 to 6, has an interval, it has a height of 7.5 centimeters, which means this has a height of 7.5 centimeters, whereas you're supposed to calculate what will be the height of the bar for the second class interval that is given to us. Now, when we draw histograms, in a histogram, the x-axis is where all the class width is written, whereas the y-axis is where the frequency density is written, which means to draw a histogram or to do a question related to histograms, to do this question which is related to histogram, we need to first calculate the frequency density. So if we are to calculate the frequency density, the frequency has to be divided by the class width. So for each one of this, I'm going to divide the frequency by the class width to calculate the frequency density, which means the first frequency given to us is given as 18. I need to divide by the class width. So the class width from 0 to 6 is a 6. So I need to divide this 18 by a 6. So when I divide 18 by a 6, I get 3. But this is the frequency density, which is 3. But this 3 is represented by a height of 7.5 centimeters, which means this 3 is represented by a height of 7.5 centimeters, means this is 2.5 times larger than this 3. So when we multiply this 3 by 2.5, that is how we get this 7.5 centimeters. Now the same way, we are going to calculate the frequency density for the second class interval that is given to us. So the frequency is 16. I need to divide that 16 by the class width that I have. So it's from 6 to 10, which has a difference of 4. So I need to divide this 16 by a 4. So when I divide 16 by a 4, I get 4. Now I need to calculate the height of the bar for that. So each bar is going to be 2.5 times larger than the frequency density that we have calculated, which means I need to times this 4 also by 2.5 to calculate the height of the second bar that is given here, that you're supposed to find, which is 10 centimeters. This will be the height of the second bar in that histogram. Let's move on to question 24. We are supposed to simplify here. We have 4 terms in the numerator. So when we have 4 terms in the numerator, we need to pair this and start factorizing it. So I'm going to do it in the side and put the factorized form here. So I'm going to pair this, and when I factorize, I can get the a out. So x minus 2 goes inside the brackets. So for minus x and plus 2, there's nothing else common other than the minus. So I'm going to take minus 1. I have x minus 2 that goes inside the parenthesis, which gives us x minus 2 and a minus 1. That is the factors of the numerator that we have. So I'm going to write it here as x minus 2 and a minus 1. I need to do the same thing to the denominator, which is a squared minus 1. A squared minus 1, there are squares with a minus, so we call those as the difference of squares. So when you have the difference of squares, you need to do it as if you're square rooting it. And the terms that you get, you need to write with a minus and a plus inside the bracket, which means the square root of a is a, the square root of 1 is 1. So I can put that a and 1 here. So now when we expand this, we will get a squared minus 1. So these are the factor pairs of a squared minus 1, which is the difference of squares. So I can write that in the denominator, which is a minus 1 and a plus 1. Now I need to start simplifying this. So I can simplify the numerator and the denominator by crossing out a minus 1 because they both are common. They both are in the numerator as well as in the denominator. So then the final answer is x minus 2 over a plus 1. So this is the answer in the simplest form. Let's move on to the next question, which is question 25. Question 25 is a derivative related question or a question related to differentiation. So when we have a question related to differentiation, now you need to find the derivative. The derivative of this is given to us already. You're supposed to find what a and k is. So the equation, the formula that is given to us is 2ax to the power 7 plus 3x to the power k. Now to find the differentiation, which is dy over dx, to find the derivative function, we need to multiply the power of x with its coefficient. So the power of x is 7. The coefficient of x is 2a, not just this 2. So we need to multiply those two together. So 7 times 2a makes it 14a. And I need to write this x with a power that is 1 less than the original power that is given here. So here the power given is 7. 1 less than that 7 is a 6. So this is how I need to write. Then I need to do the same thing for the next one as well. In the next one, the x has a power of k. This k has to get multiplied with the coefficient of x, which is 3. So 3 and k, when I multiply, I get 3k, and that will be positive 3k. And we have x, so we need to reduce the power of k by 1. So when we reduce the power of k by 1, it becomes k minus 1. So I can write it this way. But the actual derivative is given to us as 42x to the power 6 plus 15k to the power 15x to the power k minus 1. This is how it's given. So we clearly know that they have x to the power 6 here. That means this 14a and 42 are equal to each other. So if 14a is equal to 42, I can find the value of a as 42 divided by 14, which gives us a 3. I can do the same thing with the with the other side as well. So they both have x to the power k minus 1 in common, which means this 3k is equal to 15. So if I'm to find what k is, I need to divide this 15 by 3, which gives us a 5. So I now know the value of a, which is 3, and the value of k, which is 5. Let's move on to the next question, which is question 26. So this is the last question that we have here. In the question that is given, this is a question related to vectors. So it says, it states that the diagram shows a parallelogram or PQT. So this is a parallelogram. So in a parallelogram, we know that the opposite sides are parallel. So while reading the question, I'm going to mark the information so that it makes it much more easier. So this side and this side will be parallel to each other. This side O to T and P to Q will be parallel to each other, which means they have also mentioned that the position vector of P is A. Okay. In this question, the position vector of P is A means they have marked this A here. That means the position vector of P explains that it's from O to P. This gives you an idea that this O is the origin. Now that we know O is the origin, so from O to P can be said as the position vector of P, which is A, which will be the same as this side as well. So I'm going to mark that there. And the position vector of T is B. So position vector of T means O to T is B, which means P to Q, which is parallel to the same side, will also be B. And in the question, K is on PQ, so that PK to KQ is given as 3 to 1. That means this has 3 to 1 means the ratio I'm going to write it here, which means this total vector that I have from P to Q, you need to split that into 4 portions, and 3 portions out of it is going to be from P to K, and 1 portion of it will belong to K, will belong from K to Q. So I'm going to mark that as well. So when we add this 1 and 3, it is a 4. So 3/4 of B will be equal to P to K. The same way, K to Q will be equal to 1/4 of the total length, which is B. This is 3/4 of B, so I will mark that as well. So here I can write as P to K is 3/4 of B. K to Q is 1/4 B. I'm going to mention it here. The lines OK and TQ are extended to meet at X. So this is where X is. And we are supposed to find the position vector of X. The position vector of X means the vector of X from the origin, which is O, which means this the position vector of X explains that you need to find what O to X is. So you're supposed to find what O to X is in terms of A and B. So for us to find this, now for us to go from O to X, we can take several roots. So I'm going to take this root O to K and K to X. O to K plus K to X gives us what O to X is. Now, in this case, I need to find what O to K is. For me to find what O to K is, I'm going to take this root, which is O to P, and then P to K. So O to P is A, P to K is 3/4 B, which we already calculated. So I need to add these two together, which will give you what O to K is. So I can write that as A plus 3/4 B. This is O to K. Now, the next thing that I need to do is I need to find what K to X is. Now, for me to find what K to X is, I do not know what Q to X is or X to Q is, even though I know what K to Q is. Only if Q to X is known, you can find what K to X is. But in this case, we are not going to use this method. Instead, we are going to make use of similar shapes to work this out. As we know that this is a parallelogram, we know that the opposite sides are parallel. So when we have parallel lines, we can talk about alternate angles, corresponding angles, and co-interior angles. So I'm going to draw this diagram here. The diagram that the two triangles that I'm going to discuss about, I'm going to draw it here. So these two are the two triangles that we're going to discuss now. In this case, this is QX. So this is X. This is given to us as K, that is where the two lines are intersecting. This is P, this is O. This distance is given to us as A. And okay, so we will, I'm going to just skip that for now. So in this case, I'm going to prove that the two shapes are similar. So I can say that this angle will be equal to this angle. The reason is this line T to Q is parallel to O to P, means this entire line TQ will be parallel. So I can put the lines parallel like this. So these two angles are alternate angles, so definitely they will be equal. Then the next one is this angle and this angle. They will be equal as well because they are vertically opposite angles. So if two angles in a triangle is equal to two angles in another triangle, means definitely the third angle also will be equal to each other. Therefore, I can say that the two shapes given to us here are similar shapes. If two shapes are similar, if two triangles are similar, we can say that the corresponding angles are equal. So that's what we know. That's how we know that the two shapes are similar shapes. And we also know that in similar shapes, the ratio of the corresponding sides will be equal. As the ratio of the corresponding sides are equal, we already know the ratio from P to K, which is 3, and K to Q, which is 1. So we know that the ratio from P to K to Q is 3 to 1. So I can write it as P to K over K to Q is the same as 3 to 1. So I can write it in the form of a fraction as 3 over 1. These two are the matching sides. The same way, I can also say that the other side that is matching to this will be O to K and K to X. So I can say that it will also have that same ratio because the ratio of the corresponding sides will be equal, which means this will be equal to O to K over K to X. Now I already know what O to K is from the previous step. From this step, I already know what O to K is. I'm going to substitute the value of O to K there, and I can isolate to find what K to X is. So let me first isolate K to X. So to isolate K to X, I know that we have a fraction here, another fraction here. We can cross multiply them to isolate K to X. So this gives us 3 times K to X is equal to 1 times O to K, which is the same as O to K, which means if I'm to find what K to X is, O to K that I have here has to be divided by 3. I already know what O to K is. O to K is given to us. We found that as A plus 3/4 B. So this has to be divided by 3, which means the A that we have here also has to be divided by 3. 3/4 B also has to be divided by 3. So when we divide it by 3, A divided by 3 gives us 1/3 A. then 3/4 divided by 3. So if I'm to do it in the side, when you have division, dividing by 3 is the same as multiplying by the reciprocal of it. So multiplying by 1/3. So when I simplify this, I get a quarter, which means I can write it as plus a quarter b. This is what k to x is. Now that I know what k to x is, I'm going to substitute back into this step here. So I'm going to put this, you need to add O to k and k to x together. So k to x is the same as 1/3 a plus a quarter b. Now I need to add them. So I need to combine all the like terms together. So I have 1/3 a and a is a whole number. So a has a whole number of 1 in front. So a whole number and 1/3 has to be added. So 1 and 1/3 is the same as 4/3, because a whole number 1 can be written as 3/3. So 3/3 plus this 1/3 makes it 4/3. So that's the reason why I wrote it as 4/3 a here. Then I need to add 3/4 b with 1/4 b. So 3/4 and 1/4 makes it a whole, which is 1. So I can write it as plus 1b or just b, which means O to x that we have here is equal to 4/3 a plus b. This is what you're supposed to find. So we are supposed to find the position vector of x, which means we are supposed to find what O to x is, which is the same as 4/3 a plus b. So this is our answer. With that, we will be done with this paper.